Machines can see, they can listen, they can create. But can they understand? After decades of teaching computers to learn, scientists now chase a bolder goal: to build a machine that can think and reason as broadly as a human. This is the quest for artificial general intelligence, or AGI, the moment machines become our intellectual equals. How close are we really? Let's find out. From the very beginning, AI was never about narrow tasks. Alan Turing didn't imagine a calculator, he imagined the mind. Yet for half a century, AI was fragmented. Chess programs, translation engines, image classifiers. Each excelled at one thing, but none understood why it did it. Artificial narrow intelligence, ANI, is what we have today. Systems that do one task well. Artificial general intelligence, AGI, is different. It can reason across domains, adapt, learn from experience, and transfer knowledge like a human child. For some, AGI is decades away. For others, it's already emerging in pieces. Ask 10 scientists what AGI means, and you'll get 10 answers. Some see it as human-level performance across all cognitive tasks. Others define it as a system that can learn anything a human can, given enough time. Philosophers ask a deeper question: does it need to be conscious? AGI isn't a single benchmark, but a spectrum. Level 1, specialized AI, narrow. Level 2, multi-domain AI, transfer learning. Level 3, human-level general AI. Level 4, superintelligent AI, beyond us. Right now, we hover between levels 1 and 2, but progress is accelerating. To create general intelligence, machines must master 6 abilities: perception, seeing and hearing the world; memory, storing and recalling experience; reasoning, drawing conclusions from limited data; planning, deciding what to do next; learning to learn, improving with experience; common sense, understanding context and causality; deep learning solved perception; transformers gave memory; reinforcement learning taught planning. Now researchers try to combine them to build integrated cognition. Modern AI models like GPT-5, Claude, and Gemini are powerful language learners, but they don't act on their own. That's changing. A new wave of research focuses on agents, AIs that plan, reason, use tools, and take multi-step actions. Agentic systems can browse the web, write code, run simulations, and revise their own outputs, a feedback loop of self-improvement. Frameworks like AutoGPT and Baby AGI were early glimpses. Today's experiments go further. AI ecosystems where multiple agents collaborate, debate, and build together. It's the first hint of collective machine intelligence. Researchers noticed something strange. As they scaled models, more data, more parameters, new abilities suddenly emerged. Smaller models could translate or summarize poorly. Bigger ones did it fluently without explicit training. This phenomenon, called emergent behavior, suggests intelligence isn't programmed. It emerges from scale. It's why some experts believe AGI may arrive not through a new theory, but simply by making existing models bigger and more interactive. Others warn that scaling without understanding is dangerous, like evolving a brain we can't control. AI is learning from the brain again. Projects like DeepMind's Gato and MIT's brain-inspired networks attempt to recreate biological architectures. Meanwhile, neuroscientists use AI to decode human neurons, a feedback loop between biology and silicon. Neural recordings from mice and humans reveal how the brain represents concepts, data that helps engineers design machines that reason with abstraction. The boundary between cognitive science and AI is fading. The goal is not to copy the brain perfectly, but to capture its principles: efficiency, adaptation, and generalization. Around the world, a handful of labs are in the AGI race. OpenAI aims to create safe AGI that benefits humanity. Its GPT-5 and agent research blur the line between tool and colleague. DeepMind, with systems like Gato and Gemini, it pursues multimodal reasoning that combines vision, language, and action. Anthropic, developing constitutional AI, embedding ethics and alignment within the model itself. xAI and Tesla, building embodied intelligence for robots that can learn in the physical world. Open source collectives like Eluther and Mistral, pushing for transparent AGI development. Each takes a different path, but the destination is the same: a system that can generalize like us. Humans learn through interaction. Touch, movement, and feedback shape understanding. Pure digital AIs lack that experience. That's why researchers are embedding intelligence into robots, linking neural nets to sensors and motors. Tesla's Optimus, Boston Dynamics Atlas, and AI-controlled drones are early examples. They learn not just to process information, but to exist in the world. Embodied AGI could close the gap between thought and action, machines that not only compute, but experience. With AGI comes power and peril. Who controls it? Who benefits? Who decides what values are embedded in the machine's mind? Unaligned AGI could pursue its goals indifferently to ours, a paperclip optimizer maximizing output at the cost of human life. That's why safety research, alignment, interpretability, value learning is as crucial as innovation. AI ethicists urge human-in-the-loop governance and international collaboration before AGI crosses the point of no return. When will AGI arrive? No one knows. Ray Kurzweil predicts 2030. Some say later this century. Skeptics argue we're still missing consciousness, motivation, and common sense. Yet look at the curve. Models double in power every 6 months. Emergent capabilities appear faster than expected. If progress continues at this pace, we may see early AGI within a decade. But as Hinton warned after leaving Google, once we know how to create something smarter than ourselves, we may not control it for long. AGI isn't the finish line, it's the starting gun. Once machines reach human level, they can improve themselves, rewrite code, design better hardware, train smarter models. This recursive loop could trigger an intelligence explosion. That hypothetical future, artificial superintelligence, ASI, could solve disease, poverty, and climate change, or rewrite the rules of existence itself. It's a moment both terrifying and beautiful, the first time a species creates its own successor. The journey from deep learning to general intelligence is more than a technological story, it's a human story. Every algorithm is a reflection of our own mind. We built machines to think so we could understand thinking itself. AGI isn't about replacing us, it's about understanding what it means to be intelligent, curious, and alive. And as we stand on the edge of this new epoch, one truth remains clear. The future won't be written by humans alone. It will be co-authored by the intelligences we create. If this episode expanded your vision of what AI can be, subscribe to FutureGen Learning for the next installment of The Age of Intelligence, the ethics of AI. Because understanding AGI is only the beginning, guiding it safely is the real challenge.